Our next speaker, I have to tell you a little bit about Stefano. So I've been trying to work, Systems has been trying to work with another organization called GEO or GEOSS. GEO is the Group on Earth Observations, and the GEOSS is the System of Systems. It's a very international organization, and it's dealing with global data, dealing with the Earth's surface environment. And, you know, Systems represents a community that's trying to bring up and offer open source software to the larger community and apply it in meaningful ways. So I hope you listen to this presentation, because it might offer Systems an opportunity to have a greater reach than it now does through this organization. Stefano's sort of the techie person that's behind the GEOSS, and so it gives me a great pleasure to introduce Stefano Nativi, who's the head of the Division of Florence of the Institute of Atmospheric Pollution Research of the National Research Council of Italy. So, Stefano.
Yeah, thank you. Thank you very much, James, and thank you for, this great, honor to be here and try to explain you what GEOSS has been doing for the past 10 years. GEOSS has been launched in 2005, and its first, mandate is going to finish this year. Last year, the 97 governments decided to prolongate GEOSS, so GEOSS will be there also for the next 10 years. And what I will try to explain you is what we have in our mind for the next 10 years. And I'm sure that models and frameworks and networks like CSDMS can play a very, important role in order to, help us. Okay, so this is, sorry. Okay. As James said, GEOSS stands for Global Earth Observation System of Systems, and this program is managed by GEO. And GEOSS is Group on Earth Observation. This is the mission of GEO. To establish this community, share information, not only data. So I will show you that these include also social data, environmental data, models, and knowledge more generally, and try to facilitate decision makers. Not only decision makers, also scientists, of course, but this is the main mission here. It was established in 2005. And as I said, it has, now is comprised of 97 governments and 87 international organizations. It is a voluntary-based effort. That means that governments pay, and they can provide in-kind efforts. They can provide fresh money. They can provide some project or programs outcomes. In several cases, such as some NOAA or some European Union projects, they launch, specific calls in order to provide inputs and provide some help to implement GEOSS. And these are the main areas covered by GEOSS. 9 are called societal benefit areas. As you can see, we go from disaster, health, energy, climate, agriculture, ecosystem, biodiversity, water, weather. But then there are so-called community of practices. So where you have a cross boundary here, where we have some mix of all these main and overarching domains, you have a community of practice, such as air quality. Clearly, GEOSS has been dealing with the three main areas in order to, implement its goal. The first one is users. So we have a strong work plan where users are the main actors here. So they provide inputs, requirements, assessments, etc., etc. Then we have institutions. So how GEOSS can provide good practices to the different institutes worldwide in order to share their data, such as a set of principles for data sharing, for data management, etc. And then, of course, infrastructures. And I will focus on this particular area because it is my area. This is a very, an oversimplified schema of GEOSS architecture. So at the very bottom here, yes, I have the many systems providing resources. So not just data, documents, web pages, models, processing tools, etc. At the top here, we have 9 different society benefit areas, community of practices, scientists, etc. And here we have what is called the GEOSS common infrastructure. So it is a digital infrastructure, cyber infrastructure, if you like, which is comprised of people, not just technologies here. And here we have 3 main components. First one is a portal, a general portal. Then we have what is called a brokering framework, it's called an access brokering framework, a sort of middleware, and here we have a set of catalogs, registries for the internal working of the GCI. Okay, so let me tell you what we have done in the past 10 years. We started, of course, recognizing that there are many different existing data providers and resource providers on the right side here, and of course there are many potential users or clients, softwares that are interested in consuming these shared data and resources. So of course the most, let's say, the easiest thing to do was just to establish a sort of yellow page where we just took note of existing systems, and so these applications and users could go here, discover, and then bind directly. Easy, absolutely. This is the service-driven, approach, and of course, these work well, but as you can see, when you have many of these data providers and you have a lot of potential users, then you have to maintain, establish a huge number of bindings. Okay, so this is a very well-known problem in these architectural approaches where you had to maintain a lot of different bindings changing in time. As far as governance, this is very easy because this is a virtual governance. So basically GEOSS didn't have to do much just to maintain this yellow page or this catalog of catalogs, registry, whatever you want to call it. And the main functionality was discoverability. Okay, so as I said here, the problem is that users, consumers, had to establish a lot of bindings. And when I say a lot, I mean tens or, several tens of different bindings, binding to different services, because as we have seen, we have 9 different and real different society benefit areas. So, standardization, of course, is our mantra, but even if you are working with standards, you end up with different standards. So this is why we basically decided to implement a pattern. This kind of problems are generally solved in software engineering by applying a pattern, a very well-known pattern, which is called the brokering pattern. And so we develop this by introducing what is called a brokering framework. So GEOSS, GEOSS now is actually maintaining a brokering framework, a middleware framework, which is called a brokering framework. So now it's up to this framework, to this brokering framework, to mediate all the different data producers standards, and on the other side, provide what is useful for users, such as APIs or interfaces that they use. And this changed a lot the architecture and GEOSS itself, because now, as you can see maybe with the colors, now most of the effort is shifted from the providers and the user side to the GEOSS side, So now it's up to GEOSS to maintain, in this case, N+N bindings. Okay, so this was a quite change here. So also the governance change, not anymore a virtual governance, but a collaborative governance. We have to be more in touch with our providers, And on the other side, we now are able not just to discover, but also to access data, Okay, well, let me clarify that brokering is possible only because data providers and data consumers use standards, or at least well-known and public specifications, okay? This is the, approach. We start with a set of domain-specific standard baselines, so defined by experts, scientists working in their own domain. Then clearly we have what are called cyber infrastructures. So community of practices decide to implement these standard baseline, and they develop their federation system or their systems. And so only afterwards we can broker them. Okay, so we cannot skip the standardization phase, just to be clear here. Thanks to this new architectural implementation approach, we now are able to reach out to several existing cyber infrastructures. Here you can see these are some of the brokered systems. This is the GEOSS web portal. This is the brokering framework. These are the public systems and even very complex cyber infrastructure such as CEOS. For instance, CEOS federates many other existing systems, or WMO here, information system. Here we have IXU Pangaea, or US data.gov, ESA, Earth observation, cyber infrastructure. We have several, GB for the Global Biodiversity Information Facility, etc. These are the private. Recently, I think a couple of years ago, GEO decided to open this effort, to open GEOSS also to private systems and to private partnerships. So we have started also to broker existing private systems as well. Okay, so as I said, now we are brokering more than 40 of these systems and cyber infrastructures. This depicts our assets. So more than 40 systems, they publish more than 40 million of we call first level data set. They are generally time series, space series, or complex aggregated data sets. And the good point here is that 2 million are open and free. In GEOSS jargon, this is called GEOSS data core. Then if we go to the so-called lowest granularity, granules, so the single downloadable file, here we have something like 170 million potentially accessible granules, and more than 50 million are GEOSS data core, so they're open and free. And this is another view of what I have just described. These are all the 40 systems, and these are the data set provided, shared by these systems. The blue ones are GEOSS Data Core, open and free. The green ones are not open and free. When I say not open and free, generally most of them, really the largest part of them are free. But they're not open. That means that you can use it, but you cannot, redistribute, or you need something such as an account in order to, access them. So they're not GEOSS Data Core, because GEOSS Data Core means you can, just with one click you can get it, and they are completely open and completely free. And of course, we are working in order to add more. These are other systems that have been started testing interoperability. What we do generally is to establish a joint test. It is called a brokering agreement, and we jointly test it. And they don't have, we don't generally ask them to implement anything. We do what is missing, generally a mediation, in order to reach them. Okay, so clearly the number of data set and system exploded when we changed our architectural approach, and we had to face, the well-known big data challenges, volume, velocity, variety, and quality, So we had to face these changes. So this is the last architecture that I will show you as far as the present GCI. Let's say that most of the 40 systems moved in cloud, and so we had to do the same, sorry for the blue background, we had to do the same with our middleware, the brokering framework. We move it in a public cloud. In particular, we implemented APIs, standard APIs, so that other components, sorry, I don't know why here the backgrounds are not transparent. Okay, so that is the GEOSS web portal. GEOSS web portal, managed by ISA, access the middleware by using the APIs, and a set of community portals have been developed and will be, released soon, and they will also, most of them will also use APIs, cloud-based APIs, in order to access GEOS and discover access data set. And then there is the GeoNetcast. GeoNetcast is another GEOS task. It is a broadband satellite-based system, so that developing countries, so where you don't have internet broadband, so cheap, they can use it. They can access these data by, a satellite link. Okay, this is what I call a GCI 2.0 version, and as it is clear, it is a cloud-based system based on both the private and the public clouds. Governance is still a collaborative governance. Okay. Let me tell you about usage, how this system has been used in the recent years. So we publish regularly statistics on our webpage. You can go there and you can check the statistic daily. In fact, we publish statistic by day, by month, by year, and all times here. As far as the number of discovery queries finalized by the system, in particular the most searched keywords, the most searched data sources, the most used query constraints, and in particular we support both simple and the complex constraints. And these, for example, are some of the statistics published on the website. You have that for the last year, more than 400,000 queries have been received and finalized by the GCI in the first, for the next year. Our projections are more than 600,000. Basically are about to have 15,000 every 14 days. And in terms of the most searched keywords, temperature Then we have river discharge, precipitation, land cover, etc. In terms of the most search sources, here we have ICSU, Pangaea, then we have a global river discharge center. In particular, this system has been funded also by an EU project which is called GEO. We have CEOS, WIGIS, the CEOS federation that I showed you. We have the ESA, Federation for Earth Observation, European Environmental Agency, etc. And in terms of how users query the system, they generally use a keyword. They prefer a simple query by keyword. Then the second most used, most popular constraint is GEOS data core. So they look for open and free data. And then, of course, bounding box. Okay, so what we have seen basically is the GEOS architectural approaches as of 2005 to nowadays. So we started with, of course, a service-driven approach. Then we introduced this brokering middleware. Finally, we moved into a cloud ecosystem, software ecosystem. And now we are going to face the next 10 years. So what are we going to do? Clearly, we have a very specific mission, and every year there is a GEO plenary, and in the plenary they focus or refocus the mission of GEOS. Last year, the focus, the statements were very clear. We need to move on from data and to share knowledge. So basically, in terms of architecture, what we have to do is to move on from a data infrastructure to what is sometimes called a virtual research framework, And I will try to explain you, okay, we move from a virtual governance to a collaborative governance, from discovery to access, and in the next future, definitely, usability or reusability is going to be the key word. Okay, so, sorry. These are the next challenges for the technology, for the technology framework. And as you can see, a lot of new data is coming. Sorry? Oh, okay, so I have to move. Yeah, a lot of new data is coming. And what basically we are planning to do, I can go through these very quickly, is to extend our approach also to private sectors, but in particular, not just to discover and access data, but also to process data, okay? And this is where we need processing system services, models, mainly as a service, or anyway, some frameworks accessible through interfaces, standard interfaces, and APIs, such as your BMI, etc. Okay? And what we are planning is to provide a set of, I call them social services, but in particular to establish what is called a GEOS knowledge base. And then, of course, support a general portal, specific domain portals, GeoNetcast. This is the GCI 3.0 from my point of view, but let's focus on the GEOS knowledge base. Okay, I can skip this. This is taken from 2005, so the very start of GEOS. At the very start of GEOS, this was the vision, which is still there, okay? We have the, mandate to share, discover, access, and share Earth observation data, social data, models, okay? And to combine all of them in order to generate knowledge to support the decision makers, policy makers, etc. Clear, the challenge here is how can we combine all this? Here we need experts' knowledge. This is what is missing, mostly. Experts' knowledge. You are experts, for instance, GEOS community has many different domains and many different experts, And so we need to start from those experts. We need to collect formalize their knowledge and establish what is called the GEOSS knowledge base. Why? Because if you understand the picture depicted in 2005, the real goal here is to help decision makers, policy makers, to answer questions, such as how will climate change affect infection rate of dengue fever disease in Vietnam. So this is the kind of final products, final services that GEO should deliver. And clearly, in order to do that, okay, you have to combine many different pieces belonging to diverse domains, such as climatology, biodiversity, health, models, processing, services, data, okay? And social science data as well, not only Earth observation data. Now, what we have done was to develop, let me say, a quite good data infrastructure, What about models? I mean, there are several good frameworks, programs, projects, networks. Here I try just to, mention few. Then we need to integrate, as I show you, social, environmental models, how to integrate all these. And this is where we need the knowledge. We need knowledge bases along with, of course, the semantics brokers. You know that very well. You have developed your standard names because you need clearly semantics in the loop, And so these are the three main areas that we have to work for the next 10 years. Clearly, as far as data, we are a bit more confident, This is what can be called, business process or workflow if you intend in a more technological sense. This has been captured by one activity in GEO, which is called the GEO Model Web. I mean, you can read it, but as I said, to combine data models and knowledge in order to answer what-if questions. I can skip this because I'm running out of time, because I want just to show you what is the knowledge base for us. Because knowledge base is a very nice term, but in practical terms, what is a knowledge base? Well, you see, we started with a concept, Earth observation data. So a very generic concept. What we need basically is to move on and to, introduce the knowledge of what is essential variable. So what are those variables considered important by domains, by scientists, by experts in order to answer questions and produce environmental, indexes, indicators, and socio-economic indexes in order to understand how far we are to some strategic targets, okay? So this is the knowledge missing now, and in particular, we need workflows in order to, connect each other, generate indexes from essential variables from raw data, etc., and therefore to provide two main concepts, two main entry points, let me say, to GEOS. One which is called, strategic targets. The other one which is called what-if questions, okay? So that users can decide what is their entry point, because we have different user targets. And different user targets, they need different entry points, different conceptual levels. Presently, we are here. What we need, therefore, is to establish what I call a social ecosystem, GEOS, social ecosystem. So, to stay together, technology expert, domain expert, and together as a social ecosystem, try to capture this knowledge and use it. My final slide, I promise. This is, a schema where on the x-axis you have the knowledge level. Observation, essential variables, indicators, indexes. On the y-axis you have a technological interoperability development. Discoverability, accessibility, reusability. And here you have different user targets. So you have Earth observation data experts, environmental experts, global change experts, and policymakers. And of course, in parallel, you have many other possible user targets. And as you can see, if we stay here, so if we provide the discoverability and a bit of accessibility to Earth observation data, I mean, we have a huge volume of data to exchange with a relatively few number of potential users, experts. If we move on and if we put knowledge into the system, we are able to share essential variables, which are definitely much, less or much, lighter than this, and our users number increases. And of course, the same, the trend is clear here. So this is our trend. Today we are here. Tomorrow, that means in the next years, our target is to stay here, and this is the final goal, hopefully in 10 years, don't know, let's see. Okay, I think that I am out of my time. These are some conclusions, but mainly is a short summary of what I've said. Thank you for your attention.
So we have time for a question or two before our break.
Is currently all of this data, I know that, oh, I'm sorry. No. Is currently all of this data housed in a central repository? I know that you're using a brokerage kind of a platform, but just in case one of those repositories goes offline or is inaccessible, is there like a central repository that you're building where all of this data will be housed?
Yeah, thank you. This is a very good question, and the answer is no, absolutely no central repository. This is a real distributed approach. We centralize not all, but most of the metadata. Of course, we ask. They said yes. You can cache our metadata, and so we have a copy of the 40, not all of them, because a couple of them said, no, please don't do it. So clearly, we don't do it. This is the brokering agreement. But most of the metadata is there. In terms of data, no way. No way, and this is distributed. So this is what I said. We have to push a set of data management principles, and we have to collaborate. So this is why the governance is so important.
So the data integration part that you've been doing is one level of difficulty, but then the model integration within the same context of kind of a system of systems is kind of another level of complexity. I'm just wondering if you could comment on what you see to be the main challenges in moving from kind of data, making a system of systems of data sets versus a system of systems of models.
Yeah, no, indeed. This is a big challenge. Well, there are several very, challenges, but definitely, this is one of the challenges indeed. And my personal view, but I think that it's not only me, it is that GEOSS stands for global and the 2S stands for system of systems. That basically means to build on existing systems. So we definitely hope that somebody, some programs, networks, have been working on solving this problem so that we don't have to do it, okay? Clearly, as we have done for the brokering middleware, we supplement as much as possible, clearly, what is missing. But definitely, when I say discoverability, accessibility of hundreds of millions of data, this is mostly done by remote servers, not by us. We are just a broker, We just provide a sort of unified way to do it. And we would like to approach, the same for the next capabilities. Clearly, it depends on what is there, what is out there. Sorry.